Hello everyone, my name is Waffle and welcome to the 15th episode of Strats Explained, Magically Easy, a video series where I explain how and why different strats and glitches that speedrunners use work. Today we are going to be talking about one of the two main strategies for the final mission in the game, the exchange. I have to mention that this strat is a little bit slower than the optimal one, but it is much easier, so a lot of players use it. At the same time, it is much more interesting from the technical point of view, so that's why I'm making this video. The first thing we need to do is to reach the roof of the dam building. The dam itself has multiple invisible triggers that spawn your enemies as soon as you enter them. We need to skip at least one of them, and the easiest way is to fly your dodo straight to the roof. Be careful not to fly too far to the left, because that will trigger a unique stun jump. If you lost your plane or you don't use it at all, don't worry, you can take a car from a traffic, doesn't even have to be the fastest one. Then drive here and mega jump onto the building. Aim with your character model at the chimney or whatever this thing is. I already explained how mega jumps work in one of my previous episodes, a link is on the screen and in the description. Don't worry, you don't lose time by not having a dodo here, we still need to wait for the helicopter to land. Now we need to destroy it with a rocket launcher, but if you just try to shoot it normally, well, nothing will happen. However, if you make a replay with that helicopter, shoot and play that replay when the rocket is going through the helicopter, it's going to explode. After the replay ends, it's going to be restored, but it doesn't matter, the game saw it was destroyed and spawned Maria. Get close to her and the mission is over. All of that leads to at least two questions. Why couldn't we destroy the helicopter normally, but could with replays? And where did Maria come from? Oh, by the way, the name for this strat is Crashchange, and no, it's not related to how you land your dodo. Turns out if you destroy the helicopter using this interesting method, after some time your game most likely will crash. It can happen before the credits, during the credits, sometimes after the credits, and even not happen at all. As of today, nobody knows why that happens. I've heard that there were multiple attempts to solve this mystery a few years ago, but none of them were successful. And this is why this strat is too risky to use in all missions or 100% speedruns. First of all, in the current routes, the exchange is not even the last mission in the run. But even if it was, according to the current rules, you have to wait until the mission passed text on the screen, and there are no guarantees the game will make it that far. Luckily, in the most popular category, any percent, the run ends as soon as you get to Maria and lose controls, so this crash is not an issue there. This video is going to be divided into multiple parts. In the first one, we'll talk about why we were able to destroy the helicopter and why Maria appeared. In the next one, we are going to talk about the crash and everything that is known about it. For your convenience, use the timecodes from the description. For those who are curious, my game actually crashed, and that happened when I tried to skip the credits. Let's look at the mission script and see what happens with the helicopter. First of all, as soon as we get out of the mansion area, the game spawns the heli using start Catalina heli. Then it saves it into escape chopper variable. If we look down here, we'll see that this chopper gets all of the immunities, including the explosion proof one. And this is why we couldn't destroy it with a normal rocket. After that, as I mentioned, the game waits for us to go through the dam and activate all of the invisible triggers one by one. The very first one says get to the dam, but that's not the interesting part. The interesting part are these three lines. They say, if has Catalina heli been shot down, go to end of the game. And these three lines are present at every single stage. Look, if I scroll down there, you'll see there they are. If I scroll further, there they are. So, what's that end of game? Let's see what happens there. If we get there, we'll see that the game removes the timer and then removes the helicopter, spawns Maria, and when we get close to her, the mission ends. Alright, so what do we understand from all of this? First of all, developers did not want you to destroy the helicopter too early. That is evident by all of the immunities they gave it. However, developers are smart and they know, no matter what you do, someone might find a workaround and actually find a way to destroy the helicopter. And to make their game completable, they put these safe checks that progress the mission to the very end if they somehow manage to destroy the helicopter. And this is normal practice. In fact, other missions also have these safe checks, and this is totally normal. You never know what players will try to do, and they will find a way to break your code. So now we know why Maria spawns, but we still don't know why we were able to destroy the helicopter, and to find an answer for that, we'll have to look at the game code. But before we do that, I want to show you one game mechanic. If you shoot a rocket and immediately play a replay, you'll see that that rocket stays in the replay. It's just gonna be hovering, not moving. You can even touch it and nothing will happen. Grenades and Molotovs work exactly the same. It's hard to tell if it's a bug or a feature. If I had to guess, I would say feature, because to remove the rocket and then put it back after the replay ends, you need to save the rocket somewhere, and that's extra memory. In any case, this is how the game works, and this is why in the Crashchange the rocket exists in the replay, even though it didn't when we were recording that replay. I suggest we start with the class for helicopters called cheli. It's located in heli.h. There are a few interesting things, the very first one being an array for all of the helicopters. Turns out we can have only 4 helicopters in this game. The very first 2 are regular police helicopters you get when you have wanted level. This next one is a special script helicopter that we never see in this game because it's unused. And finally we have Catalina's helicopter. Let's look at the methods for this class, and the one that stands out the most to us is called test rocket collision. Let's see what it does. It takes rocket position as its argument, then it goes through all of the slots in the array that we just saw. If a helicopter exists in that slot, and if that helicopter is not explosion proof, and the rocket is flying very close to it, then we say that that helicopter has been shut down and is going to explode in 10,000 milliseconds, or 10 seconds, and the function is going to return true. Well, I say 10 seconds, but that is only true if the helicopter doesn't touch anything, if it touches a wall or the ground, and these 2 conditions check for that, then we say that the explosion timer is previous frame, so something from the past, and that means that instead of waiting for 10 seconds, the helicopter is going to explode immediately. And this is why we wait for the helicopter to land first. But let's go back to the test rocket collision function. Let's see what uses it. For that we press Shift plus F12 and we end up in, let's see, C projectile info update. C projectile info is a class that holds information about all of the projectiles, so rockets, grenades and molotovs. And we say, if it's not the time to blow up our projectile, and remember, if you just shoot at the sky, the rocket will eventually explode, even though it didn't touch anything. But if it's not the time to explode yet, we check if the weapon was a rocket launcher, and then we check a lot of other interesting things, but we are interested in the last line only. We for some reason check for the rocket launcher once again, then we check the rocket collision, and if it returns true, we remove the projectile, we remove our rocket from the game. So now we know that every time we have a real rocket in the world, we check the collision with helicopters, and if we hit a helicopter, that rocket is removed. But how often is this method called? We can guess that it's called every frame because it's called update and we already saw other update methods, but we can confirm that by once again pressing Shift plus F12, seeing that we end up in update weapons, once again Shift plus F12 for this function, and we end up in cgame process, and we see all of the other update methods, and that confirms that the rocket collision is checked every single frame. So now we know, if a rocket exists, we every single frame check if it collided with a helicopter, and if so, we say that the helicopter has been shot, and we remove the rocket from the world. But remember, that only works if the helicopter is not explosion proof, and our helicopter is explosion proof. And this is why we cannot destroy it normally. There must be something else, and that must be connected to replays because we had to use them. Let's see what's up with that. cReplay from replay.h. Once again, let's look at the methods straight away. The one we are interested in is called record this frame. You might not realize it, but while you are playing, the game is constantly recording replays. That is so if you press F1, it can show you the last moments of your gameplay. So let's see what it actually saves. Okay, there are a lot of things. Camera position, player position, hours, minutes, weather, but we are of course interested in the helicopter. And helicopter is a vehicle, so let's look at the vehicle pool. We go through every single slot in the vehicle pool, and if there is a real vehicle in that slot, and that vehicle is not an air train, and that vehicle is not a regular train, we save that vehicle. For those who don't know, air train is the plane. Okay, let's see what we actually save for the car. We have some structure T vehicle update packet, and we save vehicle health, acceleration, velocity, colors, and other stuff. Let's look at the structure and its fields to know what exactly we are saving. And once again, health, acceleration, something about doors, velocity, something about wheels, once again something about doors, and colors. But hold on a second, there is nothing about immunities. We do not save immunities, and that means that in replays, every single vehicle you see does not have any proofs, and our helicopter is not explosion proof in the replay, and this is why we can destroy it. And you might say, oh, that's another bug, right? Well, no. You see, the less fields you save, the longer replay you can provide to the player. So developers saved only essential stuff like health and visuals like doors, wheels and colors. Saving immunities is just a waste of space, especially considering the fact that most of the vehicles don't have them. But this small optimization led to such a weird and creative way of destroying a helicopter and completing the mission. There's one more thing though. During replays, mission scripts don't run, and after the replay is over, the helicopter is restored. So why does the game still think that the helicopter is destroyed? There's this function called update helis. It's called every frame, and inside of this function we will see a loop that goes through all of the slots in the array of helicopters. If a helicopter exists and its status is shot down and current time is greater than the explosion timer, that's our case, we draw visual explosions on the screen, and we saw them. After that, the game removes the helicopter from the world, and if that helicopter was Catalina's helicopter, we set Catalina has been shot down to true. What is this variable and where is it used? Shift plus F12. First of all, we see that this is the only place where we set it to true, but there is also a place where we set it to false, and that place is start Catalina flyby. Shift plus F12, and we end up in start Catalina heli. That's the command we saw in the mission script. Okay. Where else is this variable used? There's a function that returns it, and it's called has Catalina been shot down. Where is this one is called from? Well, has Catalina heli been shot down in form of a command that we once again saw in the mission script. To sum it up, when we spawn a helicopter using start Catalina heli, we set has been shot down variable to false. And as soon as we destroy the helicopter in the replay, we set that variable to true. Then the replay ends, mission script wakes up, sees that the value is true and says, oh, you must have destroyed the helicopter, good job, here's Maria. And I would say this concludes the first part of the video. I'll start the next part by explaining a few things from the world of programming. Don't worry, I will be making easy to follow analogies. What is a pointer? Imagine you have a book about houseplants, and you know there's an article about the spider plant somewhere, you just don't know where exactly. What do you do in this situation? You open the index, find spider plant, and it's going to tell you the correct page. It's going to point you to the correct page. Same thing in the game. We have an object, so an article about the spider plant, and in the game it can be, let's say, our character. And it's located somewhere in the memory. It has an address, it has a book page. And we have a pointer variable. In the book, its value is the page number. In the game, it's also a number, the address. It's just usually written in hexadecimal. Also note that objects in the memory can take a lot of space, a lot of pages in the book, but pointers, they're always small, because they're really just one number, and that's it. The next thing is a doubly linked list, one of the data structures programmers use. Imagine a regular chain. Take any link and you always know what other two links it's connected to. Or if you take the last link, it's going to be connected to only one. Same thing here, but instead of a link, we have a node. Each node has a pointer to the previous node and a pointer to the next node. This allows you to traverse the list in any direction. Node also has a pointer to some item, that's like if you tied something to every single link in the chain. The first and the last nodes point to some special value called null, or in simpler but less correct words, nil or zero. And finally, the whole list is defined by just one pointer to the very first node. So by just knowing this one first pointer, you can get to and access every single item that is stored in this list. But why do I explain all of that? Didn't we want to talk about the crash? To understand where the game is crashing, we need to take the address from this little window, open the game executable in some disassembler, go to that address, and figure out what all of that low-level code is doing. Or we can just ask someone who already did that. Nick007J told me that the crash happens in insert node right on this line. But where are we? At the very top we see a class for nodes, and it looks exactly as I just described. We have a pointer to an item and two pointers to the previous and the next nodes. After that we have a class for lists, and once again it has only one pointer to the very first node in the list. This class has a few methods to work with it, like finding items, inserting nodes, removing nodes, etc. The crash happens when we try to insert a node. This line says, if our list is not empty, so first is not null, it points to something. Then we want to take that first node and attach it to the node we want to insert. And the crash happens because first is not null. It points to something. But for some reason, that something is not a valid node. It's something else. We don't know what it is. And this is why this crash is still a mystery. How can that happen? Well, the obvious answer is developers made a mistake somewhere. But I looked through the code and nothing was wrong with it. And let's be real, this is a very simple data structure. I do not expect to find errors here. So it must be something else. Nick also told me that this function during the crash is called from physical.cpp method remove and add. And the first thing I did, I wanted to see if that method is somehow used in helicopters class. So I went to heli.cpp and I found in the function called process control a call to remove and add. So yes, this function is connected to helicopters. Let's see what it does. First of all, we get a bounding rectangle of our object, of our helicopter, and we see what sector it is located in. Hold on a second. Sectors? Well, the GTA 3 map is divided into 10,000 sectors in the form of a 100 by 100 grid, and it looks like this. Oh, well, let's zoom in so we can see at least anything. Alright, much better. Each sector is just a set of lists of stuff that is located in that sector. A list of pedestrians, a list of vehicles, a list of buildings, etc. Why do we need that? Nick assumed it was done for optimizations, for collision calculations to be more precise, and I think that makes a lot of sense. There is another list in the game that we will see a little bit later, a list of all moving things, objects, cars, pedestrians. And it doesn't make sense that if we have a vehicle in Shoreside Vale to calculate collisions somewhere in Portland, right? So we take that moving object, we see what sector it is located in, and we calculate collisions only in that sector instead of the whole map. That sounds very optimized. I found out what sector our helicopter is located in after it lands. Turns out it's these two, X20, X21 and Y58. Let's go back to the code. Here's C sector. As I said, that's just an array of lists. A list for buildings, objects, vehicles, etc. So we find all of the sectors our object is in. Then we loop through all of these sectors, and depending on the type of object, we get a list. Our helicopter is obviously a vehicle, so we either get this vehicle list or the vehicle overlap list. I'll be honest with you, I'm not really sure what that overlap means, and it doesn't really matter. All I know is, yes, helicopter can be inside of this list too. And after that, we check if we already have a node with our helicopter as an item, and if so, we insert it into the list. And this is where the game crashes. So the very first thing I did was, I launched the game, I opened Cheat Engine, found all of the lists that contain our helicopter, waited until the game crashed, and inspected the memory. And to my surprise, all of the lists were fine. Memory was not corrupted there. And this is where I stopped my research for day 1. The very next day I decided to start by launching RE3. And that's exactly what I did. I turned off all of the bug fixes, launched the game, destroyed the helicopter and started waiting. Didn't have to wait long. Roughly 2.5 minutes later the game stopped and I was greeted with this window. Assertion failed. We have the file name, the line number and even the function. Buttons at the bottom say stop, retry and skip. Well, let's open that file. And look, on line 165 we do indeed have an assertion. What's that? This is another very useful developer tool. You say, I know this has to be exactly this way. And if for some reason it isn't, the program lets you know. In RE3 they show you this nice little window. Another cool feature about it is, when your project is finally ready, you don't have to go through all of the files and remove these lines. They are going to be removed automatically when you compile a release version. This way, these lines are not going to slow down your program. In our case, we say that y_end, the upper boundary of our object, must be smaller than num sectors y, which is equal to 100. This means that some object got outside of the map. To find out what it is, we can set a breakpoint and then press skip to continue program execution. If we look at the call stack, we will see that there are no mentions of helicopters. So what is it? The this variable contains all of the needed information. If we expand it, we'll see that the object type is C projectile. And if we look even further, we can find the model ID 179. We can open default.ide from the data directory and find the ID. Turns out it's our missile. But wait a second, remember the code that says that after the rocket hits the helicopter, the rocket gets removed. What is going on? Let's see where our function is called from. Let's look at cworld process. Here we see a loop that goes through all of the nodes of the moving entities list, the one that I mentioned earlier. So what exactly is this list and how do we work with it? To answer these questions, Shift plus F12. We see a lot of results, but we are interested in the last one. It tells us to work with this list, we need to call getMovingEntityList. Okay, Shift plus F12, and this time there are not so many results. We understand to add something to this list, we call addToMovingList. To remove something from this list, we call removeFromMovingList. And we also see that this function is used in replace, and that is very interesting to us. We end up in store stuff in mem, a function we are already familiar with. I'll remind you, when you start a replay, the game saves your current environment, all of the pedestrians around you, all of the vehicles, time, weather, and a lot of other stuff, just so it can restore everything when the replay ends. And among other things, the game saves all of the objects, and our rocket is an object, so it is saved here. But it also saves all of the moving objects. Neither me nor person who reversed this code know why they do it, but they do it. And our rocket is obviously a moving object, so it's saved here too. And now it all makes sense. Let me explain what happens. So we shoot a rocket and we start the replay. Let's go back right here. When our rocket hits a helicopter, it gets removed. And let's see what exactly this function does. First of all, it adds explosions. Then it says, alright, this rocket is no longer a projectile to me. Then it says, you know what, remove this object from the world completely. And that in its turn calls removeFromMovingList, so our rocket is no longer a moving object. Okay, after that the game says, you know what, delete that object completely. We call CObjectPool delete, so our rocket is no longer an object. And that means that during the replay, our rocket is deleted as everything. It's no longer an object, it's no longer a moving object, and it's no longer a projectile. But then the replay ends, and we call restore stuff from memory. And that restores all of the objects, including our rocket. It also restores all of the moving objects, including our rocket. The only thing that is not restored, the only bit of information that we lose, is that our rocket was once a projectile. This information isn't saved anywhere. And that means that this rocket will continue flying indefinitely, because the code that is responsible for its explosion after some time no longer knows about this rocket's existence as a projectile. We lost this information in the replay. And after some time, that rocket flies outside of the map, and when we try to get the sector where the rocket is in, we know it's outside of the map, so we get something else, not a real sector. I need to explain how two-dimensional arrays are stored in memory. Here's our matrix, our grid, and for simplicity it's just 4 columns by 3 rows. Let's take any element and find its indices. From the code we know that the first index is related to the y-axis, so the row number. We can easily see that our element is located in the second row, but in many programming languages, including C++, indexing starts with 0, so it's actually the first row. Same deal with the column, it's the second column. As you can see, this was very easy, and the same way we can index any other element. However, the computer memory is one-dimensional, so the question is, how do we fit the matrix at the top into that stripe at the bottom? There are two main methods, row major order and column major order. C++ uses the former. That means that we first store the zeros row, then the first row, second row, and so on. Let's take the same element. We know its two-dimensional index is 1, 2, and we see that its one-dimensional index must be 6. How can we translate 1, 2 to 6? Look at the matrix. How many full rows do we have before our element? 1, and that matches with the first index. How many elements do we have in the row? 4. Now look at the row our element is in. How many elements do we have before it? 2. That matches with the second index, and 4 plus 2 is 6. Generally, it's the number of full rows before our element multiplied by the number of elements in one row plus the number of elements before ours in the row our element is in, or what you see on the screen. Now we can look at what happens when we get out of bounds, say an element with indices 3, 2. Plug it in and we get an element with index 14 from the start of our array. But the last element in the array has index 11. So we try to access some memory outside of our array. What's there? Memory for some other object. It can be any number here, and the game will treat it as a pointer to a list. First is equal to 691 in this example. And it's not equal to 0, so the game will try to go to this address. It will try to open this page in the book. But this page might not exist if your book is only 300 pages long. Or this address might exist, but the program does not have enough permissions to read from it. And this is why it crashes. You might be wondering, what will happen if we have 0 here? Well, the game won't crash. But we will write something least related into that address. And remember, this is the memory for something completely different. So it might cause crashes in a different place. Or maybe the rocket will fly even further until it finally reaches a place where there is a value. And the crash will just happen a bit later. The main takeaway, it will crash eventually. I'm going to be honest with you, this was not the hardest topic to investigate, but it was one of the hardest ones to explain. I really hope that all of these visualizations and analogies you saw throughout the video helped you to understand it better. It's really interesting that nobody notices these bouncing rockets, myself included. I mentioned it in the speedrunning server, and only Paladin, a GTA 3 moderator, said that he knows that it happens. It was a hard episode, and it would seem it's finally time to relax. But what if I told you it was not the only mystery tied to this strat? If you do this strat after loading the save file, you'll see that the game crashes when the helicopter explodes. And this time the address isn't helpful at all. However, if you use practice saves for speedrunning, then you'll see that the crash doesn't happen. Everything works. Let's not waste our time and try in RE3. Right after the helicopter explodes, we get the following exception, and we end up in the functions that we already saw, cworld remove. Unfortunately, if we try to look at the call stack or at the local variables, we won't get much information here. However, now we know that the crash happens in this function, so we can put our own breakpoint here. The only issue is, this function is used with cars, objects, pedestrians, etc., so it's called quite often. So what I'm gonna do instead, I'm going to put a breakpoint in a function I'm sure will be called only once when I finish the replay, and that is restore stuff from mem. Here's our explosion, and now the program stopped here. Let's go back to the remove function, put a breakpoint here, continue, and now we're back there, but this time we have a proper call stack. And it looks like we are trying to remove Catalina's heli. Okay, let's see. We are expecting an object of type CEntity, but what we actually got is CPlaceable, and that's weird, and this is why the game crashes. Because you see, we are trying to call this remove function on our object. If we look closely, we'll see that class CEntity has this function. However, class CEntity is based on CPlaceable, the object that we actually got, and CPlaceable does not have a remove function. This way we are trying to call something that doesn't exist, and well, the game obviously crashes. But what is this object? We can easily see it by finding the model ID like we did before, and it is right here, 124. Let's go back to our text file, and that is a train? So, it turns out that we are trying to remove Catalina's helicopter, but instead of the helicopter, we get a train which is no longer even a train, just a CPlaceable. How does it happen, and where do we go next? We can do another cool thing, and that is add a watch. What we do here is we put a variable that we want to look at, and we get its current value. But what is even better, right mouse button, break when value changes. And this way the program will stop whenever Catalina's helicopter is changing to something else, and this way we can see when it changes to the train. Let's restart the game and see what happens. The game stopped for the first time and the value changed from 0 to something else. And that is logical, the game spawned the helicopter for the very first time. Let's see where we are. We are actually in cheli update helis, and that is a bit weird because you see, this function is called every single frame. So how do we spawn only one helicopter? Well, it turns out there is this variable called Catalina heli on, and if this variable is true and Catalina's helicopter model is loaded and Catalina's heli doesn't exist yet, then we spawn one. And this is weird because, you see, we're not saying, game, please spawn us one Catalina's helicopter. We are saying, game, please keep spawning Catalina's helicopters if one doesn't exist at the moment. And that is true as long as this variable is true, so let's see what it is. And we are pressing Shift plus F12, and we see that there is only one place where this variable is being set to true. And that is in start Catalina flyby, the function we already saw today. I'll remind you that it's called from the command start Catalina heli, the script command that we saw in the script. So far so good, let's continue. We destroy the helicopter and the value changes again, this time to 0. Once again, nothing weird here, we destroyed the helicopter, so the game just removes it. Let's continue. Oh, the game stopped right away, and we are once again getting a new helicopter, the value changed from 0 to something new. Oh yeah, this is what we saw earlier, the game will keep spawning Catalina's helicopter if one doesn't exist, and ours just got removed because we destroyed it. Turns out this value is still true, so let's see when is it false? Wasn't it supposed to change already? Once again Shift plus F12, and we see that it is actually right here. Remove Catalina heli. Where is this function called from? Shift plus F12, and we end up in command remove Catalina heli. So that's another script command. And scripts, they don't run during replays. So this command didn't have a chance to run yet, meaning that the value of that variable stayed true, and we got a new helicopter. But hold on a second, we know that everything that appeared inside of a replay will be removed because we will be restoring the original environment, and that helicopter was not a part of the original environment, so it's gonna be removed. But you know what's not gonna be changed? This value down here, it's gonna stay the same, and the game will be thinking that it points to the helicopter. However, in reality, it's going to be pointing to the vehicle pool slot where that helicopter appeared in during the replay. And to understand what's going to be located in that slot after the replay, we first must determine what slot it is and what was inside before we started the replay. I added a few more watches. The very first one is the pointer to the current slot in the vehicle pool, and we see that its value is 1. Our helicopter just spawned, so we understand that it spawned in slot number 1. The next is all of the slots. We can open any, for example the first one, and see what's inside. Let's scroll a little bit further and we'll see that vehicle type heli, which means that our helicopter is most likely located in slot number 1, because we don't have any other helicopters currently. And finally, flags, once again for every single slot in the pool. And what the value means is, if it's 128 or higher, then the slot is empty. If it's less than 128, then it is occupied by some vehicle. And we see that the first slot has something inside, and we just confirmed it was our helicopter. So now we have just two questions. Is it always gonna be slot number 1? And if so, what was located inside of that slot before we started the replay? Let me answer the first question. In 99.9% of cases, it is going to be slot number 1. And here's why. Let's look at the code that is responsible for spawning vehicles that needs to be spawned during replays. So when a replay spawns a vehicle that was inside of that replay, it calls new with the slot that it wants to spawn that vehicle in. So we call new, that calls getVehiclePool new, that calls setNotFreeAt, and we create our vehicle for that replay in the slot that we wanted to create it in. But we also change the pointer, and here's how we do it. We start with 0 and go through every single slot in the vehicle pool. And if that slot is free, we are just going to return. What you need to know about pools in this game is that it is very hard to spawn something in slot number 0, meaning that in most cases it's going to be free. So the value will be 0, and when the game will create the next vehicle, it's going to spawn in the next empty slot after the pointer. So the next empty slot after 0, and it happens to be slot number 1. I have another video where I explained how pools work a bit more thoroughly. If you're curious, watch it, link is on the screen and in the description. But let's go back to slot number 1. What was inside before we started the replay? I restarted the game and these are the values I got. The pointer is pointing to somewhere, and that's okay because the traffic cars are constantly getting created, then constantly getting removed, and the pointer is moving accordingly. But what we are here for is the first slot, so let's open that, open C vehicle and find the vehicle type. It's down here and it's currently equal to vehicle type train, so it is a train after all. But why does the game crash? Can't it delete a train? There has to be something wrong, and this is what we have the other value for, the flags. The flags for the first slot are equal to 129. What does it mean? 128 or higher means that the slot is empty, so there was a train, but it is no longer here for some reason. And now it makes sense. The game crashes because it tries to delete something that doesn't exist anymore. But where did it go? I don't know, but it's not hard to find out. We're gonna do two tests. In the first one, we'll start a new game. In the second one, we'll load a save file. In both cases, we'll look at these values and see how the slots are getting filled. Trains are among the things that are getting created at the start, so we should see what's different. So I once again put a breakpoint on the value change and started a new game. Let's see what happens now. Looks like we got our first vehicle, and we are indeed making trains. Each railroad carriage is a different train, so we're gonna be making them for a while. Let's continue and I'll stop when something interesting happens. Alright, looks like we are now creating planes, and that is also expected because they're also created at the start. There are multiple of them, so let's continue. And the cutscene started. Let's skip it. And looks like we are creating something from the script now. Let's see. Yep, we are calling command create car, so we reach the mission script. Let's see what we have in the flags. The first slot is occupied, and what's inside? Once again, let's open it, see vehicle, look at the vehicle type, because it's the easiest thing, and it is of type train, meaning that we indeed have a real train in the first slot when we start a new game, and this is why it doesn't crash when we do Crashchange. Same deal, but this time I loaded the save file. Let's see what happens. Okay, we created our first train. So far so good, everything looks exactly the same. Let's continue. Wait a second, the value just decreased, it was 19 and now it's 18. Looks like we are deleting some stuff. Shut down for restart, clear for restart. Huh? Are we gonna continue deleting planes? Yeah, looks like we are. And well, now we are probably deleting trains. Is it gonna go all the way? We've just deleted the last train, now we have nothing in the pool, but well, we must create them again because we know that if we load the save file, trains exist. What's gonna happen now? And yeah, looks like after a bit of delay we got our new train, but this time it spawned in slot number 2, as expected. If we continue, we'll see that we spawn more trains, but this time it's called from initialize when restarting. So what do we understand from all of this? Well, it turns out that if you load a save file, the game for some reason creates trains and planes twice. So it first creates them, then it removes them all, and then creates them again. And with this configuration, both zeros and the first slots stay empty. And we can see it right here, look, values are 128 or higher. And this is why the game crashes if we do the strat starting from a save file. Finally, why does the game not crash if we're using practice saves? Here's our first train. Here's our final plane. Now we just deleted it, we already saw all of that. Back to an empty pool we go, and what happens next? Oh, something new, the value changed from 1 to 0. Let's look at the call stack. It seems like we are now loading vehicles from the vehicle pool. And now it makes sense, because you see, these practice saves, they have vehicles stored outside of the garage for convenience. So you have the right car at the right moment and you don't have to go and look for one. And these vehicles, since they're not in the garage, they're loaded immediately as soon as you load a save file. And if we look here, we'll see that they are also loaded in the slot we want to load them in. And as we saw earlier, that means that after we spawn them in that slot, we change the pointer to the first empty slot, and once again, in 99.9% of cases, it's gonna be slot number 0. So that's why the value changed to 0. And now the next vehicle that is gonna spawn is going to spawn in slot number 1. Guess what it's gonna be? You're damn right, it's another train. So this way, trains are created in the same slots as if we just started a new game. And that's why the game doesn't crash. So, how do we fix all of that? I think that the right move here is disabling projectile logic during replays. This way, the helicopter is not going to be destroyed and the rocket is not going to be removed in the replay. Alright, it's finally time to sum it all up. The first crash happens because the replay prevents the rocket from being deleted properly. It flies endlessly until it finally gets outside of the map. The second crash happens because when you load a save file, even if you just launch the game, the trains are created twice, and that results in the first 2 slots in the vehicle pool being empty. Next, due to all of the things we discussed earlier, the game thinks that the helicopter, Catalina's helicopter, is located in one of these 2 slots, and it tries to delete it, but since that slot is empty, the game crashes. However, having a mission-marked vehicle in your save file makes the train to appear in the slot where the game expects the helicopter to be in. So when the game tries to delete the helicopter, it actually deletes the train, but has no issues with it, so everything works. If you're still watching this somehow, let me give you your challenges. The first one. We already know what happens if the rocket goes outside of the map along the y-axis. What will happen if the rocket goes outside of the map along the x-axis only? Let's say x equals 100, y equals 10. The second one is gonna be harder. I don't know if you understood it or not, but the first crash is not related to the helicopter at all. Tell me another method that will lead to this same crash. Code on the screen is a hint. And this is it from me for today. A poll for the next topic is already live. Click the link from the pinned comment and choose the option you like the most. If you enjoyed this video, leave a like, and if you don't want to miss the next episode, consider subscribing. My name is Wofil, see you the next time.